Hey, it's Trip here from the 87th. This video is part one of two parts talking about the instrument landing system in BMS 4.33. Information is current as of update 1. This first part will take us from our present position to the TACAN at Seoul Air Base. Then we'll intercept the 050 degree radial outbound to the initial approach fix at 13 DME, which is the start of the TACAN ILS approach to runway 19 at Seoul. Then we'll intercept the 13 DME arc and fly that around to a point where we intercept the localizer inbound, and that is where this video will end, and part 2 will pick up at that point and talk about just flying the ILS approach itself. So right now we're 10 miles from Seoul at 6,200 feet. I've set up the DED with the numbers from the approach plate. The approach plate can be found in the docs section of your BMS directory. It's again the TACAN to ILS to runway 19. And on that page tells us that the localizer front course frequency is 110.9, the course is 189, and the TACAN is 46 X-ray. If the ILS is not already on, you need to go down to the left side panel, and with this ILS rotary, turn it to the on position. And that completes the setup there. On the HSI, I have I've set the 050 degree course with the course select knob on the HSI, horizontal situation indicator. So that's set on 050. Now I am terrible at video editing. As a matter of fact, I have no experience whatsoever. So for you to stay oriented, not only looking at the approach plate, but I have put a steer point line that emanates from the Seoul TACAN, and it goes out along the 050 degree radial to the initial approach fix. And so what I want to show you is, by setting 050 on the HSI, you can see the same presentation as you would see if you had this steer point line set up. This is not going to be there unless you set it up, but you won't need this once you get proficient at interpreting what the HSI is telling you. So from here we can see that this is our aircraft symbol, and you can see our ground track has taken us to the Seoul TACAN, and that's the same thing we're seeing here. The airplane here is taking us up this line to the Seoul TACAN, and then we're going to turn right and intercept this 050 degree radial outbound from the TACAN, and that's what's going to happen here. We're going to come up to the Seoul TACAN and turn right and intercept this radial outbound. So hopefully this will help with orientation. Now I've set up almost a worst case scenario. This is quite an acute angle here that we're coming into the TACAN station, so it's going to require that we maneuver somehow so that we can intercept this 050 degree radial outbound without too much difficulty. If I was in my little blue airplane and coming from this direction, for instance, then I would proceed direct to the TACAN station, and it would be a nice right-hand turn and intercept the 050 degree radial outbound, no problem. Or if I was coming from over here toward the station, again, not a problem intercepting 050, but when you have these high acute angles like this, you can see that that's going to happen to you on the HSI, and this is part of the planning that you need to be doing as you're descending into Seoul and flying direct to the TACAN. You need to ask yourself, when I get to the TACAN station, which way am I going to turn? And so you have a few options here. One option is you can fly past the station and make a right-hand turn and try to intercept the 050 degree radial outbound, but that's probably not going to be working out for you too well, because as you pass the TACAN station, being that close to the station, you're going to be passing radials at a very fast rate, and you probably are going to overshoot the radial outbound, and you're going to get over here to the other side, and you're going to have to intercept it back the other way. So you're going to be S-turning across this radial, and you're not going to get established on it with the CDI centered until you're probably 9 or 10 miles from the station, and you're getting close to the point where you need to be thinking about turning onto the 13 DME arc. So coming to the station at this angle and following that ground track is going to be problematic. So you could fly direct to the station and then fly past the station about a mile or two and then turn left to a heading that will parallel this radio, and that heading would be 230. So if the radio's on 05, you just come to the station and turn left to a heading of 230, go out about 5 miles. Now you can make this left-hand turn and intercept the radio inbound, and then once you pass the station outbound, you're all squared away on the 050 with the CDI centered. Of course, the deviation indicator is centered, and now you're all set up to make that lead turn onto the radio, onto the arc. So that's what we're going to do in this instance here. And just to back up, just to talk a little bit more about how we're approaching the TACAN station. Yeah, it would be easy to just make a slight turn here and intercept 050, but if you were in the airplane over here and you were headed toward the TACAN station, you probably would want to not turn in this direction and try to intercept this radio outbound. Again, you're working real close to the station, and it would be problematic. So the best thing to do would be, again, to just hit the station and then turn left to a heading of 230, and then come around and make your intercept out here on the other side of the station, and then just continue to fly over the station and out on the 050 degree radio. Same thing if you were situated over here, you would come in here and just make a turn to 230 and make a right-hand turn and intercept back inbound. So as I said, you need to think about that before you hit the station and ask yourself suddenly, you know, which way do I need to turn? So you want to stay ahead of the airplane as far as you can. And one thing that will give you more time to do that sort of planning is if you slow your airspeed down. So right now we're 10 miles from the TACAN and we're doing 310 knots. We could afford to be doing quite a bit lower speed than that. I would say around 230 or 240, depending on the gross weight, but I think that'd be a comfortable speed. So that would give you more time to figure out the solution here as to what you're going to do. So slow up a little bit. Okay, so what we're going to do is pass the field, and I'm going to put the airplane on run, and I'm going to go up here. Now this is what it looks out the window. Of course, when you're in IMC, you're not going to see this, but looking at the HSI, that's the beauty of it. You got the whole bird's eye view of just exactly what you're going to do. You're going to come up this way. We're always on the tail of the bearing pointer. So if this is the head of the bearing pointer, this little white triangle, and let's see if we can get it to move. No, well, let me put it in nav. I think I can get it to move. There we go. So you can see the head of the bearing pointer is connected to the tail of the bearing pointer. All right, so they move together. So if I'm going directly to the station with the head of the bearing pointer under this lubber line at the top of the HSI, then the tail must be telling me what my position is from the field. So I'm northeast of the field. I'm on the 060 degree radio. So I'm coming up this line. The center of the HSI represents the TACAN station. Okay, so when I get to the TACAN station, I'm just going to start a left turn out to 230 and then go about 5 miles or so and make a left turn back inbound, all the while just keeping the course arrow on 050 and just playing my turn so that I center the CDI as I approach the TACAN station, coming back toward it. Alrighty, now a couple things to say about TACAN and Falcon. When your steer point that you've selected, in this case we're on steer point 2, and steer point 1 is also Seoul. I've taken off and my destination is back at Seoul also. But when your destination and your departure field are selected, then TACAN and nav are the same. In other words, if I have this instrument mode selector in nav, I'm going to read a bearing of whatever that bearing is to the station and that DME. When I take it to TACAN, the bearing hasn't changed. I'm still on that same bearing to the station and the same DME. Now that's true, as far as I can see, of all stations in Falcon except one, and that's Kunsan. If I'm at the end of the runway with the parking brake set, ready to take off on runway 18, I can look out the window to the right and I can see a little TACAN station over there. If I select the tack end position on the mode selector, the bearing pointer will point off to the right toward that tack end station, and up here in the HUD I can read the slant range to that station. Well, if I'm on the ground, slant range is the same as horizontal distance, so they're the same. Now if I take the instrument mode selector and I put it to nav, now this bearing pointer is going to move from pointing to the tack end. It's going to move over here to some point over here to my left, which is the geographical coordinates for the airport. All right, and whatever distance it's going to read, you'll see up here. So for Kunsan only, the tack end and the geographical reference point are not co-located. Every other air base that I've been to, I've actually driven over taxi lights and runway lights and found myself parked right on top of the tack end location, and then I've switched the mode selector to nav, and there wasn't one iota bit of difference in the bearing and the DME. The DME stands for distance measuring equipment. So all but Kunsan. So for this approach, the point I'm making is I can use these numbers up here for my distance information. Normally these numbers never have anything to do with tack end. They're only steer point information. But since they're co-located here at Seoul, I can use these numbers to read distance. It's a lot easier to read these numbers than it is to squint and read this little DME number here. Now if I had track IR, yeah, I could zoom in and look a little clearer, and if you want to do that, that's fine. But even with track IR, I find that I do most of my flying with my eyes looking through the HUD, even in instrument conditions, and I can read these numbers a lot easier. So that's what we're going to do. Procedurally, you'd want to put the selector in tack end, but you may find it in nav, and that's okay because they're telling me the same information. The other interesting thing I notice about the tack end and the nav is that this number, as I said, was slant range. This number down here is your ground distance, as if you were on the ground driving to the station. This is your ground distance. So I'm at 6,200 feet. I'm about 6,000 feet above the elevation of Seoul, which is about 1 mile. 6,000 feet is about 1 nautical mile. So when I drive over the top of this tack end station, I'm right over the top of it, this slant range is going to be 1 mile, because slant range, when I'm right over the top of the station, is looking directly down, and that's my slant range, so it's going to read 1 mile. And this number is going to read 1 mile, the tack end DME. And that's correct. That's modeled correctly. That's the way it is in real life. So this number, when I'm at 6,000 feet, this number is never going to get less than 1. It used to be that it would read all zeros, but now it's not going to read less than 1. If I was at 12,000 feet, that's 2 miles above it. So this number, as I approach the station and then go past it, will never read less than 2. So it's just an interesting fact about what you're seeing here. All right, so what we're going to do is, as I said, we're going to overfly the station, and I'm probably going to turn out this way a little bit. As a matter of fact, I am going to turn out because I want to create some displacement from this this extension of the 050 degree radial going this direction. I don't want to turn so that I'm right almost over the top of that radial going the other way, because when I make my left-hand turn to come back in, I'll immediately overshoot and then just have to correct back to the 050 when I'm back inbound. So what I'm going to do is I'm just going to hit the station and maybe turn like 20 or 30 degrees to the right and go out here about 4 or 5 miles. There's no limit to how far you can go out. There's no holding pattern here. We don't have any approach control to talk to get permission to do anything, so we just, we're our own approach control. So I'm going to go out to 4 or 5 miles, and then I'm going to start a nice little left-hand turn, and if I do it just right, I'll roll wings level inbound, and the CDI will be centered, and then I'll be coming back to the station. And at that point, I'm just going to overfly the station and continue to fly outbound to that point where I need to start thinking about leading my turn onto the arc. So let's let the aircraft roll here and we'll see how that works. So as we cross the station, notice the slant range and the HUD there and the ground distance in the HUD. Just an interesting fact. Now I've made this graphic here, this line. As I said, I'm no good at video editing. So this emanates from the TACAN station. That's the 050 degree radial. So that's an easy way for you to visualize what's going on, and hopefully it will help you see that what you're seeing on the HSI is exactly what would be happening, you know, as you travel over the ground. Alrighty. And we need to start slowing up. We got plenty of time to slow up here. We're heading outbound. We're in no hurry here. We're trying to slow things down so we have time to think. Alrighty, now as we get close to the station, you don't want to start chasing this needle. This needle gets real sensitive. You don't want to start going left and right, you know, with your headings, trying to keep the needle centered. Just let it stay where it is, let it fall if that's what it wants to do. I mean, it will fall. If it's not directly at the top of the HSI, it'll fall to the bottom of the HSI instrument. In this case, the needle's to the right, so it's going to continue to fall to the right as we go outbound, and you can see it start to move now. Alright, so this number's never going to be less than 1. I'm going to go back up top here, and when this number starts getting bigger, I'm going to start my turn about, I'm doing 244, so I'm going to turn to about 270. Yeah, about 270 would be good. So I'll go back up here and just kind of hold what I got here. Speed's looking good, looking for 270, and I'll roll wings level. So what I'm trying to do is I'm trying to create some spacing. I'm trying to displace myself from this extension of the 050 so I have some turning room to turn back inbound without overshooting too badly. So right now we're at 3 DME, and we'll go out another mile or so and then make that left-hand turn back. Now, most of my flying, as I said, is up here through the HUD, even in IMC conditions. The instruments down below are primary instruments. You have to refer to these in your cross-check, but most of my attention is up here in the HUD. Alright, we'll start a 30-degree bank. The speed's gotten a little high, and another thing that'll help you with your turn radius here is a lower speed. So the lower your ground speed, the less likely you'll be to overshoot the radial inbound. So just hold 30 degrees, nice comfortable bank angle for instrument work. You don't want to pull a lot of G's or excessive bank angles when you're flying instruments. Everything's slow and gentle. Alright, let's go back down to the HSI and see how we're doing. We got a lot of distance here in terms of bearing change to make this turn. I don't know what this mileage is here, but I can see the bearing change, and right now we're on 050 and 070. We got 20 degrees of bearing change here to go. Let's see, the autopilot's going to get a little bit low here if I get the speed too low. But anyway, right now we're just kind of playing now the CDI and our intercept angle. The CDI hasn't started to move, so I might want to roll out just a little bit of bank until it does start to move across. There, it's starting to move. So depending on how fast it's moving, the closer the CDI gets to center, the closer I want my heading to be on 050. Now if I start to overshoot, the worst mistake I could make is to put in 45 degrees of bank and pull a lot of G's to try to turn faster. You don't do that, you know, flying instruments. You just accept the fact that you overshot and then you correct back the other way. But this is turning out pretty good. I'm going to roll out on 050. We've only got 5 knots of wind. I think it's out of the south, so it's blowing us to the left. But I'll put in a little bit of a correction, just a degree or two, and that should keep us on the 050. So now we're inbound to the station. The bearing pointer's at the top of the HSI, and the DME's getting smaller. So we're good to go. All we have to do now is go out to that lead point for our turn onto the arc. And you can see what's happening here. We're still coming up to the station, and then we're going to go outbound to that 13 DME fix, the initial approach fix. So again, as we get close to the station, if the bearing pointer starts to move, we don't really go chasing it. Just accept the fact that it's going to fall as we pass the station. So we'll see that happen here in a second. So we know this is not going to get less than 1 mile. When it gets right at 1 mile, then we're over the top of the station, and that's when this bearing pointer is going to start falling. So let's see exactly where we are. We are 1.2 miles. This probably won't get less than 1, and then it'll start increasing. Tadpole's telling us that we've passed the fix, and now it started increasing. So now we're going outbound on the 050. Alright, looking pretty good. Speed's around 340. I like it. I'm going to freeze the airplane here and talk about this lead point that we want to calculate. When we're going from a radial and then turning onto an arc, so in this case we're going to go 13 DME and turn left 90 degrees to establish ourselves on that arc. There's a rule of thumb that we use to determine when we're going to start our turn. If I was to wait until I got 13 DME here and then started my left turn, by the time I turned 90 degrees to the left, I would be out around 14 or 15 miles, and that's 2 miles outside the arc, and I'd just have to correct back toward the arc. So I want to lead it by some predetermined amount, and the way you do that is you take your ground speed, and I could change the scale to ground speed, but it's not necessary. This is just a rule of thumb, just an easy calculation to make. Just accept this as your ground speed. We've got 182 at 5 knots, and so the wind is coming from this direction, so it's going to add maybe 7 knots to our ground speed to this speed, so it's only going to give us 240. So 1% of 240 is 2.4, and you know what, I just round that to the nearest whole number. So I'm thinking 2 miles is where I want to start or establish my lead. So if I'm going to put myself on a 13-mile arc, then at 11 miles is where I want to start that left 90-degree turn. And if I do it right, as soon as I roll out 90 degrees to the left of heading change, then my DME will be right at 13. What we're doing down here on the HSI, we've just passed the station. The needle hasn't quite settled down yet. It should center up here as we continue on, so I don't need to change my heading just quite yet. But what we're looking at on the HSI is to make that 90-degree turn to the left, because that's what the approach chart calls for. It's an arc to the left or an arc to the north. Excuse me. We want to turn to a heading of whatever's 90 degrees off our wingtip, and that would be right here at 320. This little indication here, the little indice is 90 degrees to our current heading. So just look at that number, and then in the HUD you can just turn to that heading. Or another way to do it is, you don't even have to go that far. All you have to do is, when you're turning left 90 degrees, you're causing the head of the bearing pointer to come up this way around the HSI. And when it gets to this point right here, the head of the bearing pointer gets to this point here, then you will have turned 90 degrees. And so that's what I'm cross-checking, is just watching where this bearing pointer is, because I want to watch this bearing pointer. If I get into a position right here and I'm only on the 12 DME arc, then I know I probably want to roll out wings level and let this bearing pointer stay in this position or fall slightly so that my DME will increase. Anytime the head of the bearing pointer is below this wingtip, you're increasing your distance from the station. And anytime you put it up here, then the distance from the station is getting smaller. So what arcing is a series of wings level, straight and level flight until the, well, let's say you rolled out with the bearing pointer right at 13 DME. If you roll wings level, the bearing pointer is going to fall, as it will. Anytime your wings level, the bearing pointer is going to continue to point to the station, so as you're going away from the station, the bearing pointer is going to fall. And when it falls, say 5 degrees, then you turn like 10 degrees of heading turn, in this case 10 degrees to the left, and that'll cause the head of the bearing pointer to come up to where it's 5 degrees above the left wingtip. And so your roll wings level, you wait till it falls down below, till it's 5 degrees below, and then you do another 10 degrees of heading turn, put it back up here, and so you do a series of those turns, and that'll maintain the 13 DME arc. Now another technique is, depending on what your ground speed is, excuse me, you can put the airplane in a 3 or 4 degree bank, depending on your ground speed, and if you do it just right, this head of the bearing pointer will stay right on this wingtip, because you're turning to the left as fast as this bearing pointer is trying to fall, so it has the effect of staying right there. So try putting it in 3 or 4 degrees of bank. If 3 degrees is not enough and you see it falling, then you might want to go to 4 or 5 degrees, but some small bank angle, and that'll keep you from having to make these wings level adjustments, you know, letting it fall, you know, 10 degrees and then bringing it up and letting it fall again. So that's a good technique to use to stay on the arc. Alright, let's see. I'm going to put the airplane rolling again, and we're still at 6,200 feet. The minimum holding altitude out here, according to the approach chart, is 6,000 feet. So if we're above 6, we're in good shape. If we came in here at 10,000 feet, there's no way that we'd want to start our arc from 10,000 feet, because we have to go down to 3,700 feet during the arc. That would be too much altitude to lose in too short a period of time. So you would use the established holding pattern to just hold at 13 DME while you're descending down to 6. And then you can intercept it like we're doing outbound. And now you're at 6,000 feet and you're ready to begin your arc and your descent. I've put a vertical velocity scale up here in the HUD. If you don't have that up, you can use this vertical toggle switch here and put yourself a vertical velocity scale. And that way I don't have to look down here to see my vertical velocity. To maintain the arc, I'm going to use about a 2,000 foot per minute rate of descent. So I'm going to put this caret on this indice here, and that'll give me a 2,000 foot per minute rate of descent. Right now it's showing a slight descent because our airspeed's getting a little bit low and the autopilot can't handle it. So in a second here I'm going to take the autopilot off and, oh heaven forbid, try to hand fly the airplane. Yeah, so if the caret gets more than below this mark here, then you don't really know what your rate of descent is unless you refer down here where you have a larger scale. So I'm going to try to keep it at or just slightly above the 2,000 foot mark. So just before we get to 11 DME, which is where I'm going to start my turn, I'm going to come down here and put the course selector on 189, which is the front course. So I don't want to be doing that while I'm in the turn. So when I get to about 8 or 9 DME, I can put this on 189 and I'm still going to be on, you know, the 050. The wind's not going to blow me off that badly. So I'll have that all ready to go for the intercept of the localizer. Alright, let me take it off freeze here and try to help things out a little bit. I'll go back down to the HSI, and it looks like I need just a slight correction to the right toward the CDI. That amount of deviation on the CDI is not a problem. I mean, you're considered to be on course with that indication. That is plenty good. I hate flying down here because the reason I hate it is this scale on the ADI, attitude direction indicator, is so small. This is 5 degrees of pitch attitude from the horizon, that little bit of space right there. But in the HUD, here's 5 degrees down here, so you have a much larger scale here. You can be more precise flying up through the HUD. I really don't like flying down here. So your vertical velocity is just almost uncontrollable because you just can't quite seem to find the exact pitch that you need to maintain a vertical velocity. Alright, well, we're at 7 miles. So I'm going to go ahead while I'm down here and just rotate this around to 189, which is the front course. And I got that set up. It's a good time right now to double check that you've got the ILS tuned. I mean, nothing would be worse than making that turn from the arc onto the localizer and then find out that you don't have the ILS on or properly tuned. So make sure it's on the right frequency, the right course setting. So you want to double check things when you have time. Alright, so when we get out to 11 DME, we'll be making that turn. And our speed's a little bit low. Let me get rid of the autopilot. I think it's off, yeah. Alright, try to hand fly this thing. So slow is good. 230, 240 knots on the arc is a real good place to be. So you can see by the, let me freeze it for a second. I don't have to have this on 050 to know if I'm on course or not. I can look at the tail of the bearing pointer. The tail of the bearing pointer is on about 049 or so. There's 050, so I'm only just, you know, a wee bit off. If I want to get that bearing pointer, tail of the bearing pointer right on that 050, in this case I would turn away from it slightly, so I would make a right-hand turn of a few degrees. Now, I think I mentioned it, whenever your wings level, the head of the bearing pointer, let's say the head of the bearing pointer is over here, it's pointing to the station. And if your wings level, the head of the bearing pointer is going to fall toward the bottom of the instrument. Well, if the head of the bearing pointer is falling, then the tail must be rising. So that's the rule. The head of the bearing pointer always falls, and the tail of the bearing pointer always rises. Now, the only time it can't fall or rise is if it's exactly at the top or the bottom of the instrument case. Then it's gone, you know, as low as it can go or as high as it can go in the instrument case, and you're not giving it a chance to fall. So anyway, the tail of the bearing pointer always rises. So the way I determine which way I want to turn to get this tail to be on 050 is a little memory aid that I have. It's called Trout, just like the fish, T-R-O-U-T. The OUT stands for outbound, so this is the technique I use when I'm flying outbound from the station. And the T stands for the tail of the bearing pointer. So just find the tail of the bearing pointer. The R stands for the radial that you want to intercept, in this case 050. So I want to go from T to R in the same direction and keep going in the same direction, and then roll out on a heading over here. In this case I'm only a degree off, so I'm only going to roll maybe to 060 at most to get this tail to fall, or to rise rather. And then when it rises up to 050, then I turn back to 050 heading, and I'll be right on the radial outbound. So go from the tail of the bearing pointer to the radial you want to intercept, and then go in the same direction. Depending on how much split you have here, you need more intercept. And then roll out on that heading and wait for the tail to rise up to that radial that you're trying to intercept. Alright, so that's a technique that can help you. Okay, let's see, where are we? We are at 9 miles. We're coming up on 10 miles. We're going to start our descent and turn at 11 miles. So it's going to get busy here. All we're doing is we're turning to put the head of the bearing pointer up on that left wingtip. Alrighty, autopilot's off, autopilot's off. Looking good. Alright, there's 11 DME. Start our turn, power back a little bit. I'm going to use some speed brakes here. Pick up a 2,000 foot per minute rate of descent right at 30 degrees of bank. Now I can use this tadpole here. That's pointing right at the station too. It's right at the field rather. So that kind of gives me an idea. I'm 45 degrees of turn right now. If I go down here, I can see the head of the bearing pointer is right at 45 degrees. So I'm looking pretty good. I'm going down to 3,700 feet. And speed's okay. Speed's a little low, but it's fine. Alright, I'm going to roll out with the wingtip, bearing pointer right on the wingtip, which is right about there. As a matter of fact, I'm just going to put in like 3 degrees of bank. Let's see if we can keep it there with 3 degrees of bank. So I'm at 4,600 feet. I'm going down to 3,700 feet. Speed's looking real good. We're staying right on the DME. Everything's looking pretty good. So let's talk about the next thing we're looking for. And we're always thinking about what's the next thing we're looking for. I'm going to freeze it here. I've got 200 feet to go, and then I need to level off, because according to the approach chart, I can't be below 3,700 feet unless I'm within 13 DME inbound. And so I'm going to maintain 3,700 feet until I start that turn. Now, down here on the HSI, I have to know when I'm going to start my turn inbound. And there's another rule of thumb for that. So just as we calculated a lead point when we're going from a radial turning onto an arc, now we need a rule of thumb to give us an idea of when to turn when we're going from a arc onto a radial. And so the rule of thumb is we take whatever the distance is for the arc, in this case 13-mile arc, and we divide that into 60. 60 is kind of like a magic number. And so there we get 4.66. Well, I round that up to 5. And then we multiply that by the same number we used to lead the turn previously, that 1% of our ground speed. So again, my ground speed is going to be closer to 200 than 300, so I'm going to use 2 as the number. So 2 times what I say 5 is 10 degrees. So I don't know what this is in mileage, so I have to have the rule of thumb in degrees. So 10 degrees is the number I'm going to use. And what that means is when this head of the bearing pointer gets within 10 degrees of what I have set in the course selector, in other words, when it gets to 199, that's when this CDI is going to start to come across, and that's when I'm going to start my constant rate 30-degree bank angle turn over to 189, the inbound course. Now what I don't want to do is I don't want to leave this switch intact I don't want to put this switch in ILS and wait for this CDI to break case or come across the come off full scale deflection, because when I'm in TAC-in, this full scale deflection represents 10 degrees of bearing change. When you're in ILS mode, this deflection here represents 2.5 degrees of bearing change, so it's 4 times as sensitive. So if I were to put this in ILS at this point and just sit here and wait for this to come across, as soon as this starts moving, it would come across the face of the HSI so quickly that I wouldn't have time to make a 90-degree turn before this CDI not only got to the center position, but it would slam across to the other side, full deflection over here, and I would go right through the localizer course instead of rolling out on the localizer inbound. So that's why I leave it in TAC-in until I get some movement on the needle here. And in this case, it just so happens that it's 10 degrees, which is the same as the full-scale deflection. So when I see the CDI start to move, then I'm going to start my turn, left turn to 189. When it gets to 1 dot deflection, and that's the terminology, this is 1 dot, that represents 5 degrees of bearing change. Then I'm going to switch to the ILS mode and then complete the turn to intercept and hopefully intercept the CDI centered, which means I'm on the localizer course inbound. Now when I start making my turn in earnest toward 189, then I'm considered to be within 10 degrees of the inbound course, so I can continue my descent according to the approach plate down to 2,800 feet. Now I can't go below 2,800 feet until I'm 10 miles from the TAC-in, so I'd have to level off at 28. So as soon as this breaks case, I'm going to start my turn to 189, and I'm going to continue my descent, or start my descent down to 2,800 feet. So that's going to happen pretty rapidly. All right, so let's. I'm going to go back up stairs, and like I say, I like to fly with occasional glances down to see how my progress is. So let's take it off freeze and fly. All right, so I'm right at 13 DME and looking for 3,700 feet. I got to level off here best I can with these instruments. Looking up here, there's 3,700 feet. All right, speed's a little high, I don't know, probably looking pretty good, but not bad. All right, 3,700 feet. going to roll out here because I don't want to keep turning, otherwise my DME will get too small. If you're within a half mile of the arc, you're in real good shape as far as tolerance goes. Speed's a little bit low. Alright, that CDI is going to start coming across because I can see a 10-degree split between the head of the bearing pointer and the course selector. There it comes. So I'm going to start my turn here and continue my descent to 28. When I get to one dot deflection, right about there, I'm going to switch to ILS and then go upstairs and complete my turn with reference to the localizer needle there. It's starting to come in from the right to the center position, and hopefully I'll roll out here. Looks like we're going to overshoot it just slightly, leveling at 2,800 feet, but just keep my turn going here. It's okay to overshoot. You always correct back toward the needle, not a problem. Now that steering cue there, that little tadpole with the flag coming out the top right there, that's telling me what heading to fly to intercept the localizer. It's kind of cool. Alright, so I'm going to stop the video here. This is where the second part is going to take up. It'll be concerned with just flying the ILS approach. So I think that's all I wanted to say about everything, and I hope this helps, and trip out.